In this video, we want to evaluate the integral of x to the third multiplied by the square root of 4 minus x squared. So what method of integration do we use for this one? As it stands there, we could probably use, I'm pretty sure we could use a trig substitution. In this case, we'll be looking at the substitution involving sine of theta. We look at this as a squared minus u squared in those formulas. But I'm going to try the method of integration by parts. So I'm going to break it up this way. It'll be x squared there, this will be x, and then this will be the square root 4 minus x squared. And this will be dx then. So I can differentiate the x squared obviously, and with this x over here, breaking it up in these two parts, derivative of 4 minus x squared is a minus 2x, and I got the x there. So I can let my u equal to x squared in the formula, and my dv will equal to the square root of 4 minus x squared. And this will be my dx here. So I'm going to differentiate the u, find the integral of v. So remember the product, the answer for integration by parts will be whatever you have for u multiplied by the value of v, and that's to be determined here. And then it's going to be minus the integral of v du. And then of course you have to go back to the original variables for any kind of substitution. So let's just say this, and this will be du, taking derivative here. Derivative of x squared will be 2x, and then this will be dx. Now we have to differentiate, or I'm sorry, integrate this. So taking the integral, so this will be v here, will equal to, and let's work this like a separate problem. So I'm going to let, and that's just for this part, okay? I'm going to use u again. I could use u1 or t, so keep that in mind. So this u, of course, is not going to be the same as this one. So let's let u equal to 4 minus x squared. So now we're looking at the integral here. So integral of dv here will be v. Now we're working this separate integral. So du equals to minus 2x dx. And then we make the substitution here, and I forgot my x here, so I got an x here in front. I put it right there. That's an x. And then from this right here, x dx will equal to du divided by negative 2 here, so this will be, put a du over 2. And this will be a minus right there. So I'm going to make my substitution over here in this integral here. This will be the integral of, and I'm going to replace the x dx, so x is there and then dx is there. So that'll be replaced by minus du over 2. So I'm going to put the minus 1/2 out in front. And then this will be u, 4 minus x squared, that's my u. And that's to the 1/2 power. Instead of the square root, I put a 1/2 power here. And this will be du. This is then minus 1/2. Now I'm going to integrate here with respect to u. It means u to the 1/2. U to the 1/2, I just add 1 to this. So that'll give me u to the 3/2. And then I divide the coefficient negative 1/2 by that. Same thing as inverting and multiplying. So I get this. So then this gives me, the 2's cancel out, I get a minus 1/3. Then I'll go back to the original variable here. U then is 4 minus x squared, and the x wanted is 3/2. Now we can set this up now. So this is the way I broke it up. So then my next step then, I'll go ahead and eliminate this. But now, using the method of integration by parts, then I have my u here, and I have my v over here. So the first part, right here, uv, that's the first part of the answer. So I take whatever u is, and that's x squared multiplied by this, the v. X squared multiplies this, I'll just write it like this. So it's going to be a minus x squared, that'll be over 3. Again, that's u, and then what we got for v. And then this is 4 minus x squared, and that's to the 3/2 power. And then the next part here is the minus. So I have a minus, and then it's the integral of, and it's v. So we have v right here. So that'll be minus 1/3, and then it's 4 minus x squared to the 3/2 power. And that's multiplied by, okay, right here, du in the formula. Du is 2x dx, so I'll put it over here. So this will be 2x dx. So now we have to simplify this integral here. So let me put this over here, equals then. Let's just rewrite this, minus x squared over 3. And then I got this 4 minus x squared. This is to the 3/2 power. And then I'm going to rewrite this. I'm going to put this minus on in front, leave it there. And I'm going to bring the 1/3 out also. It's a constant. You can always do that. If it's a constant, you can take it outside the integral. So So 1/3 comes out, this minus stays, and this minus right here, I'm still going to have 4 minus x squared to the 3/2 power. And this minus right here in front of the 1/3, I'm going to put it with the 2x, so it's going to be minus 2x dx. So to solve this integral, I would use another u substitution, so it's identical to pretty much what I did a while ago. I would let u equal to 4 minus x squared, and then take the derivative of that to get du, and then du, and let me just do it here real quick. So it'll be u minus, I'm just going to set it up here because it's the same thing I did a while ago. So it'd be u again equal to 4 minus x squared. So du would equal to, derivative of this will be, derivative of 4 is 0, derivative of minus x squared is a minus 2x dx. So just bear with me here. So now look at this, this minus 2x, this minus 2x dx, this will be your du, that'll be your du, so that's gone. And then this 4 minus x squared, that's going to be your u. So all I'm going to have there is u to the 3/2 du. I integrate with respect to u, add 1 to the 3/2, that's 5/2, divide the coefficient by that, and then I just go back to the original variables. So all it's going to involve here is this then. Notice the first part, that's already done. So this is still going to be minus x squared over 3, or minus x squared to the 3/2. So again, what do I do here then? Add 1 to the 3/2. That gives me 5/2, divide the coefficient, so this will be a minus 2 over 15. And of course this was u, but we went back to the original variable, so this would be 4 minus x squared. And then the exponent increased by 1, so this is going to be 5/2. And then you have your constant of integration. So using the method of integration by parts, and of course in the process of doing that, we used a u substitution twice, the standard u substitution twice, to get a final answer of minus x squared over 3 multiplied by 4 minus x squared taken to the 3/2 power minus 2/15, minus 2 over 15, multiplied by 4 minus x squared to the plus the constant of integration. You want to try the trig substitution and see if you get the same thing or something very similar. You might have to make a few modifications, but this worked pretty good. So thanks for watching. We'll see you next time.